Hi, everyone. Welcome to the webinar, Unlocking Edge AI, Advanced Features of Edge Impulse. My name is Linda Watkins. I'm SVP of Marketing at Edge Impulse, and I'm really excited to welcome you. I see a few of you have already started to introduce yourself, so please feel free to do that. Let us know where you're dialing in from, what you do. We'd love to hear more about you. You can do that in the chat, should be on the right-hand side of your screen. This session will be recorded and a link will be sent out afterwards in case you missed anything. Also a reminder, you may have seen this on our promotion for the webinar, we are doing at the end of the webinar a giveaway, a Jetson or a Nano Dev Kit. I have it right here. So it's a random drawing that we'll do at the end of the webinar. Everyone will be on mute, but we definitely want to get to your questions. We have a great team that's here to answer questions throughout the webinar. We also have time at the end for questions. So put your questions in the Ask the Speaker section, and we'll make sure we get to those. So now I want to introduce our amazing speaker, Louis Moreau, Head of Developer Relations at Edge Impulse. Louis started his career developing a low-power and GPS-based IoT solution to protect rhinos in Africa. When not hacking hardware or automating tasks, you can see him riding an electric skateboard in northern France or scuba diving in tropical islands. So I'll keep that short because we have plenty of things to go over today. So with that, I will turn it over to Louis.
Thanks a lot, Linda. I'm super excited to be here today with you. I've seen plenty of familiar names in the chat. So yeah, my name is Louis. I live in France and I lead the developer relation team. So the main question we are going to at least try to answer in this session is how to scale your Edge AI pipelines. So to do it, we are going to divide this main sections. The first one is how to automate your data pipeline, so how to aggregate data, how to validate or disqualify data samples, how to prepare and combine data to arrive to an ML-ready dataset that is ready to be trained. Second part will be around model optimization and how to build models. So I'm going to explain the difference between multi-impulse, multimodal, sensor fusion, how to extract meaningful features using neural network embeddings, how to develop and train your model only based on your data using the Eon Tuner search spaces, and how to constrain the hyperparameter searches. And then I'm going to tease you a bit around the visual anomaly detection. So it's a feature that we've been developing for quite some time now, and it's about to get released. Not quite yet, another few weeks, I believe. But it's or in a very good state, so I've been able to test it extensively. And then finally, we are going to see what deployment options are available, what to choose depending on your journey, whether you're just testing the platform out, you're integrating your solution, or you want to scale and make it ready for production. I also have a special announcement to make. We are releasing today a super cool feature, or at least an improvement of a super cool feature. Stay tuned until the end of the webinar and you'll know more. First of all, a first question for you. How familiar are you with Edge Impulse? I think, Linda, the question is here. I'm going to wait for a couple of seconds to get your answers. If you're just curious, I've never tried it, perfect. You'll learn a lot today. If you're already an expert, that's good. You might learn something. Super excited to hear about your answers.
Okay, I'll close the poll now, and then we'll share the results for anybody that's curious to see how folks answered.
Shall I wait until the...
It takes a while to process, so why don't you go ahead and then we'll share these results before the next poll.
Awesome. So just before we get started, I wanted to give you two ML pipelines example. One is around the health wearables. So I'm not going to cover all the details. So we are working with several customers. to automate the data pipelines. And one of the pain points in those use cases is how to handle large-scale clinical studies. So we've been developing features within Edge Impulse Studio, especially in the organization section, to answer those needs. We will cover that a bit in more details later. And the second one is around industrial machine learning pipelines. So once you train your model, you then want to integrate your model or to push your models to the world. And usually you do that through an IoT platform. So whether your model are deployed directly on a gateway that gather different sensor data or directly on the machines, on tiny microcontrollers, this can be done as well. So during the first part, we are going to see how to automate your data pipelines. This is done mostly through the organization features of Edge Impulse. So feel free to try. There is a free trial. And why do you want to automate your data pipelines? It's because first, getting gold standard labels is hard. So gold standard is actual label that reflect the reality. It's hard, and it's super important to make your model as robust as possible. And if you can catch errors early, it's perfect, because we know for a fact that collecting data is an extremely costful process. So to automate your data pipeline, first step is to aggregate your data. So we provide a way to link your buckets to your organization. Usually it's done through cloud buckets, but you can also directly upload your data if you want. We've got the uploads portal to do so. I'm not going to cover the uploads portal in this section, but you can have a look at it in the documentation. So what is a cloud bucket? It's basically a cloud storage that you can link to your organization, and then we can retrieve or just read the data. So you can navigate to the data section on your organization, then click on buckets and click on add bucket. You just need to fill a couple of credentials, usually your bucket name, the region, your access key and your secret key, and then your endpoints, and you're free to go. We've got a connection. Once you've got that, you need to create an organizational data set. We have two options in Edge Impulse to do so. First view is a default dataset, and the second view is the clinical dataset. Clinical dataset, it's a bit historical, although I'm using it for many other things because it gives you some extra power. It's because we've been building these views and features around like the clinical studies. But yeah, feel free to use it for other purposes as well. It's not only dedicated to clinical studies. The default view, it's super simple. It's basically a file-based view where you can drag and drop some files. Please note that this will be added to your bucket, so make sure you've got the right credentials if you want to do that. Then you've got some actions, for example, to run transformation jobs. I'm going to explain that later on dedicated directories or files. On the other hand, the clinical view, this one has three layers. So the dataset itself, it's a larger set of data items grouped together. The data items that you can consider as a directory, but has some extra parameters or extra features, such as metadata or even checks if you want to validate that your dataset is okay. And the data files, so the actual files themselves. You can also have an easier filter, so search bar to search for your data. This is super convenient. And it's a great way to validate your data through different checks. So you might want to, for example, go through some things that are very basic. So first, are all the files present? Imagine you want to merge two files together. You first want to validate that the accelerometer and the gyroscope data CSV, for example, are present, and then you can merge them together. All the labels are present. This is something maybe you want. You have another text file that contains your label. If this is not present, you might not want to use it. You can do some more advanced checks. I'm going to come back to it in a minute. For example, if you have any correlation. And the main idea is to catch errors early before your data is actually in your ML-ready dataset, so you can train your model. So get rid of the data samples that you don't want. And to do those, to validate or to apply those checks, you can use transformation blocks. here is an example of the so how to correlate data between a medical device, so polar HR, so heart rate, and a PPG, where we're extracting heart rate as well. On the left side, you might want to validate the data. On the right side, you might want to disqualify the data and not use it in your machine learning data set or in your machine learning pipeline. And then once you validated all your data, you need to create a data set that is ML ready. So in Edge Impulse organizations, any file can be added in any formats. However, to import it in an Edge Impulse project that is going to be trained, you need to respect some formats. For example, on images, you need to use JPEG or PNG with or without bounding box. We support plenty of object detection annotation formats as well. But it has to be in the right format. Same for video files, where you can extract some frames to then use it as an image, audio, or even JSON or CBOR files, but they need to be in the right Edge Impulse data acquisition format. CSV file is the same. We have a kind of a strict format, but we also have a feature called the CSV wizard that helps you parse those CSV files. And to convert all these different formats into a format that is ready to be ingested, you can use transformation blocks. Now, I've been speaking a lot about the transformation blocks. What are those exactly? So it's basically a Docker container with some extra information. So a Docker container is basically a self-contained container where you have your application that you can write in any languages. So if you're familiar with MATLAB, you want to write your transformation in MATLAB. If you're more familiar with Python, do it in Python. Node.js, I know our CTO use a lot of Node.js in those transformation blocks. Then you package everything together with the dependencies, and then we add a couple of extra parameters on top of that, such as some variables that you can fill directly in Edge Impulse Studio. It's pretty easy to use, especially when you get started with some examples. And to push your blocks to your organization, just do Edge Impulse block init and then Edge Impulse block push, and this will be made available in your organization. Another question for you, how familiar are you with Docker? I give you a couple of seconds, minutes to answer.
Yeah, so go ahead and put your answer in. There's 3 choices. You've never used it. You could be super familiar with it or maybe somewhere in between. So go ahead and put in your vote. And I'm going to close the poll in a second. Okay, great. We have lots of votes now. And before I share the results of that, I will share the results from the last poll, which is how familiar are you with Edge Impulse? A lot of folks are just discovering the platform, so that's great. Some beginners, about 33%, intermediate 20%, and experts 3%. So that's a distribution that I would kind of expect because it's a lot harder and a lot more time to become an expert. And then the Docker container results, it looks like kind of split between familiar with Docker, never used it, and then 23% quite familiar with it.
Oh, that's great. So yeah, we use Docker a lot in our custom blocks. If you're familiar with them, you already know. They are super useful, especially because it's a self-contained package. Anyway, I see that many of you are already familiar with it. Then transformation blocks, how do they operate? How do they operate? So we have 3 main modes for Edge Impulse transformation blocks. The standalone mode, so no data is passed to the container, but you can still access some data if you need by mounting your bucket into the container. I've seen a couple of solution engineers who use the standalone mode to synthetically create some data, for example, using DALI from OpenAI. Here you can just just with a prompt create some data, and you can supplement your data set. This is super useful. You can operate at the data level item. So we pass the in directory and out directory arguments. So the transformation job will run on each directory present in your selected path. And the file level, kind of the same, but we operate on the files level, so in file and out directory arguments. Sometimes, especially when you get started, it can be a bit tricky to understand the concept. So I've prepared a GitHub repository that contains plenty of different examples on how to do this. Feel free to have a look. It's available at github.com/edgeimpulse/transformation blocks. We will add more in the future as the need comes. And then once you've got all your checks, data parsing ready, you can stack different transformation jobs together to create a data pipeline. And this can be fully automated. So you can run at a given interval, like hourly, twice a day, once a day. You can fetch data externally, combine the data together, parse them, and add them directly to an Edge Impulse project. It can also send you an email when new data arrives in your bucket. Once you have that, your dataset is now ML ready and it's ready to be trained. You might notice here there is a view that you might not be familiar with. It's the multi-labels. So it's super useful, it's super handy when you want to see like a full state, for example, like some sleep patterns, some machine conditions. And you can see on the white line, that's actually the state or the label of your file, of your data sample. This is something else. Okay, so I've been wrapping up like the first part. Feel free to ask questions. Either some of our moderators will answer you, or I can take some questions at the end. And now we'll see how to build and optimize your models. With Edge Impulse, we try to keep an Edge AI first approach, and most of the platform is hardware aware. So the idea is to let you create models that can run effectively on Edge devices. I wanted to take some time in this session to explain the main differences between multimodal, sensor fusion, multi-impulse. What are those? So I'll go through the definitions. So running multi-impulse refers to running two separate projects, so two completely different projects, different data, different DSP, different models on the same target. So how to merge two projects together in the exported C++ library or in the exported package. Running multi-modals refers to running two different models, so same data, same DSP, but two different models on the same target. For example, if you run a motion classifier and you add on top an anomaly detection on the same device. And sensor fusion refers to the process of combining different data from different type of sensors to give more information to the neural network. I tried to summarize that a bit in this graph. So really on the left side, multi-impulse, you can see two projects. In the middle side, you can see one project, but you combine two learning blocks together in the end. And on the sensor fusion, especially using neural network embeddings, we are going to see that in the next slide. You combine first the data, then you can use different DSP blocks depending on the data that you want. Then you combine the output features together in a learning block, and you arrive with an export package. So how to do that for the advanced sensor fusion using neural network embeddings? I'm going to be pretty quick, I have to say, because it's basically it's super complex to do that manually. We are here to help you if you want to automate that step. But yeah, that's I'm mostly going to explain why neural network embeddings has a real value here. So if you have a look at the first on the left first default approach. When running separate DSP blocks, you're constrained in the choice of neural network in the end. So for example, because the features that are extracted can be fundamentally different. So for example, a spectrogram and a data point from an accelerometer has basically nothing to do. They have distinct characteristics. And this incompatibility makes it challenging for the neural network to use convolutional neural networks that we know that are particularly useful for high dimensional data, such as images or spectrograms. So as a result in here, you might need to be forced to use fully connected layers. that might not be suitable for your kind of projects. So to bypass this limitation, you can use neural network embeddings. So in one dedicated DSP, you stack together the audio or the high dimensionality pre-processing with some neural network embeddings. And the other side, you can use another kind of DSP. And then the output features of those would be perfectly suited for fully connected layers, for example. I'm going to explain, give some more details. So let's take the example of a spectrogram. So the input here is the extracted features from the spectrogram. Then you create a neural network using convolutional neural networks. And at some point near the end, you cut this neural network. So you remove the classification head, usually done through a softmax layer. And what you obtain is the embedding. So it can be actually features that can then be passed to another neural network, a fully connected one. So each layer of the neural network will start acting like a feature extractor, but it will be highly tuned for your data. In practice, how do you do that with Edge Impulse? So first, you need to prepare your data set. So combine in your data samples all your axes. So audio here on the example is audio X, Y, and Z from motion, so motion and audio. Then train a first project for your high dimensionality data, in that case, audio. Train the model as you would do normally with Edge Impulse. Download the TensorFlow save model. We're then going to extract the embeddings from it. You can also download the test data. If you need to quantize your model, we can apply some post-training quantization. Use this script. It's probably easier than having to replicate that by hand. Use this repository. We provide a script called save model to embeddings. You pass some input and the output. And I'm not sure if you can see properly, but in the test that I did, you have like the full neural network architecture where you can see at the end, you've got your softmax, so your classifier. And in the output ones, we remove the last layers to obtain the embeddings on the output instead of a classifier. Once you've done that, you need to encapsulate your neural network embedding in a custom DSP block, and then push that custom DSP block like you would do for the transformation block. So Edge Impulse block init and Edge Impulse block push using Edge Impulse CLI. Then you can create a new project and use this custom DSP block plus another one, train it normally. And lastly, you need to merge or modify the exported C++ library for declaration implementation of the custom DSP in the main.c++ and compile and run the application. And now your model has more information that are highly tuned for your data. I know this can be a bit complex. Our solution engineers know how to handle those kind of things, and they can help you to automate all these steps through custom blocks and to help you to integrate this workflow in an ML pipeline. This is actually what we have done for the multi-impulse. So I'm going only to show you the simple way, but if you want to have a look at the really complicated way on how to merge all the files together, feel free to have a look at the full tutorial. So how we did that? So we create a custom block. So it's a custom deployment block where you just need to pass two API keys of your two projects, and the output of it will be an impulse that contains the two projects merged together, so you can run it effectively on device. Keep in mind that this is for the C++ implementation. If you're using Linux, it's usually way easier. You can reference two runners using different EAM files. I'm going to cover that in the last section. And then here is an example on how to run the multi-impulse. So the use cases was if you hear a glass breaking sound, you can then launch another impulse to check if on the camera there is a person or not. So this can be used, for example, on a security application, a smart security camera. Cool, right? I know it can be a bit tough, but here it's advanced features of Edge Impulse. Another question for you: what is the main problems you are trying to solve with Edge AI? This is I'm really excited to hear about your problems. And if you have any question, feel free as well to reach out even after this webinar. We'd be happy to see how can we help you. I'm going to give you a couple of seconds to write down your
This
answer.
one's an open-ended question, not multiple choice. So go ahead and just take a minute to type in your answer here. As you do that, a couple reminders: keep the questions coming in the Ask the Speaker section. We have folks monitoring those questions, but also you can upvote different questions that you see that you also have that question. And then the ones that are upvoted the most, we'll make sure we get time at the end to answer live. So we'll get a couple more answers in before I close the poll of what is the main problem you're trying to solve with Edge AI. And I'll share these results later, so I have time to look through them, but I'll close the poll now and turn it back to Louis.
Cool, thanks, Linda. And then, okay, another cool thing that I wanted to mention, so anomaly detection. So this can run in a standalone mode or on top of a classifier. In that case, we have multi-models. But I mostly wanted to cover that because I've been testing the visual anomaly detection, and I have to say it's great. I'm going to show you that in a couple of minute or in a minute. So how anomaly detection work? Usually it's working through clustering algorithms. So based on your data, so nominal data, we try to group them together in different clusters. And then when you run the inference, if this data gets close to the cluster or within that cluster, it can be considered as no anomaly. On the other hand, if it's far away from the clusters, it will have a high anomaly score, and we can consider this as an anomaly. So how this is done, like the default approach is the same. You have some input, usually some nominal data or like normal data. We extract some features from the DSP block, and then we use clustering algorithms such as the K-mean or GMM, which stands for Gaussian mixture models. This is great. It works great for basic sensor data, but when it comes to high dimensional data, it tends to not perform as well as like deep neural networks. We cannot really extract or learn the complex patterns. So we got inspired with our FOMO models. FOMO stands for faster objects, more objects. And in that case, we just, like we do with the embeddings, we remove the classification head and we replace that with some GMM, so Gaussian mixture models. And it only requires to be trained on normal data. And each cell in that case will tell you that there is a chance of an anomaly. It has almost the same performances as FOMO, so up to 30 frames per second on the Cortex M7, and within like 200 kilobytes of RAM. This video is quite old. We've been showing that in the past. So all the square, so rectangular box are nominal data, and if you add something else, it will tell you that it's considered as an anomaly, so it highlights it. I've got okay. I've been training two projects on it. This one is using BinTech dataset. So only on the left are the nominal data, which follow like a regular pattern. And if you have a close look at the anomaly one, you can see the pattern differs, so the signature is different. And then we can just output in the anomaly results where it is, so where is the anomaly. Same for this other data set that contains a machinery piece, where the data on the left is the nominal data, and the two other data samples are data that contains defaults or defects. You can see on the middle one kind of an impact where we do highlight it, and on the other one, like the piece is completely broken, I believe. So we highlight like different anomaly scores at different spaces. So that's super cool. I'm really excited to see what you will build with the visual anomaly detection. This has not landed yet in the studio, but will get released very soon. Then, when you don't know where to start, so you've got your data set is ML ready, but you don't really know how to get started. Our Eon Tuner is great for that. It's our auto ML tool, but not only, it's also auto DSP, it's hardware aware, so it's great. So for those who are not familiar with the Eon Tuner, that's the view that you can get. So we basically test plenty of different combination, and then give you the best combination of DSP and learning blocks within one view, and you can filter that based on your anomaly validation accuracy, your testing accuracy. You can constrain it. For example, you want your model to stay like within 50 kilobyte of RAM. So you have these options, but sometimes you're constrained by your hardware, by your expertise, and you want to constrain the search spaces. So for that, you can use the Eon Tuner search spaces. Let me give you like 3 examples. Your project requires to use a grayscale camera because you already purchased it. So there is no point in testing all the RGB models. Or your engineers have spent hours like working on a dedicated signal processing technique, and you know for a fact that it works, then you want to use that, but leave the neural network or the learning block more open. Or same, like you've got great data scientists that know for a fact that a machine learning architecture is great for this kind of data, but you just want to adjust a couple of last hyperparameters, and then you can do that as well. So how this works, it works using templates. So a blank template looks like the following. You have input block, DSP block, and learn block. When I first tried it, I was a bit confused. In the end, it works basically the same as, I'm not sure if you're familiar with ML Flow, for example. So this is the search spaces. They work basically the same. And what I recommend when you get started is to load the templates. So we have some pre-made ones, but you can also train a first project and then use this impulse as a template, and you can modify the parameter. So each element inside an array is considered as a parameter. This means that you can stack several combinations, and yeah, it can contain several elements. So this is super useful. It has saved me like hours and hours, probably like 100 of hours, instead of having 20 different projects trying different combinations. This is really a great tool. It saves a lot of time. So that's the end of the second section. Now we are going to see the deployment options. Again, feel free to ask any question in the chat. I'll try to answer as much as possible at the end. Now, what deployment options do you have? So you might want to deploy your edge AI models on gateways, on Linux-based inference small edge servers. You might want to just deploy them on tiny MCU, on MCU with some AI accelerator. And I don't think I'm mistaken if I'm saying that we are the platform that integrates with with as many silicon vendors. We support plenty of different deployment options, whether it's on camera, on gateways, on sensors, on wearables directly. Here it's only like all the silicon partners we work with are not here, or all the kind of boards that we support either. For example, I don't see a Raspberry, ESP, is Arduino here? Yeah. But yeah, so we work with various vendors, and we integrate our tools, our deployment, or our models to leverage all the hardware acceleration when possible. Then, as we've got plenty of different options, you might wonder, okay, what do I choose? So I have to say, this really depends on which stage you are with your ML journey. Whether you just want to, so for example, if you just want to test the platform, use your mobile phone. I haven't put it here, or your laptop. This is super easy. But then if you're thinking of deploying that on a real hardware at some point, and you're just prototyping, choose the Edge Impulse firmware deployment option. So this is super easy. It already includes hardware acceleration. It includes sensor sampling. And it's available for many development kits. So whether you're using a dedicated MCU or system on chip, you can have a look. We probably have a dev board that supports it. And it's super easy. You just, with one command, so the output of Edge Impulse will be a binary that you can flash directly to your device. And then with one command, you can test that your model actually works. This is on the MCU side. On Linux side, if you're just exploring and quick prototyping, I suggest that you use the Edge Impulse Linux CLI or Docker. So we even provide a web interface, so everything will run locally. And we also leverage hardware acceleration on x86, Arch64, ARM v7, or macOS. And basically what it is, it's a wrapper for the .eem file, which is our Edge Impulse models for Linux. And we also provide like audio and image data sampling. Now, if you're okay with it and you want to move one step further in your journey, you want to start implementing your custom solution. So on the MCU side, you want to, for example, take the C++ library or the extracted package for a silicon vendor, such as with the IR Kill that we just announced, or Simplicity Studio components, or I'm not going to quote to cite every vendor that we have, but you want to take that package and library and implement it in your custom application. So we do include hardware acceleration when possible. We have plenty of documentation. And for each of the solution, we also provide a standalone example. So you know how to run from the code, you know how to integrate that within your main application. On the Linux side, you can use the Linux inferencing SDKs that use the .aem, and we have a Linux inferencing SDK for Python, Node.js, C++, and Go. It also includes hardware acceleration. We include documentation and plenty of examples, especially on the Python one. We've got some interesting examples. And then once you're happy, you've got a strong custom implementation for your application, you eventually want to go to production. So you want to scale that. And to scale this, we have the custom deployment blocks. So either on the MCU or Linux side, you can package all your custom integration together, and the output of Edge Impulse, so after the deployments tab, you can just have either a binary, a Docker package that you can then pass to your fleet management system, and then get that deployed everywhere. And as soon as you get some new data, you retrain your model, this will automatically regenerate your full application. So this is super cool. We've got plenty of options. I've got a question for you. What Edge AI hardware are you using already or planning to use?
Yeah, another open-ended question. So just type your answer in here. As you do, I looked at the responses from the other survey about what is your use case. Basically, what are you using Edge AI for? There are a lot of answers around anomaly detection, predictive maintenance, some just, working on discovery, cough detection, sensor fusion, sound detection. So a lot of interesting use cases. I'm always so interested to hear what folks are working on. So I'm going to close this poll now, and then we can share those results later.
Awesome. And then, so we're arriving to an exciting part. This is something we're releasing today. And I'm happy to announce that we're releasing the Ion compiler RAM optimized. So you're probably familiar with our Ion compiler, which provides some, which helps you to save some RAM, latency, flash, etc. And now we are opening a new variant of it, which is the Ion compiler RAM optimized. So it will help you to save even more RAM. And why we spent the last few months to develop that is because we noticed that in many of our customer use cases, they were RAM constrained. So when you're RAM constrained, usually when you have less RAM, you have smaller MCUs and you save cost on your bill of materials. So that's super easy to understand. And by analyzing our machine learning architectures, we identified that most of the RAM usage was used to store these intermediate, also the intermediate results, especially in convolutional neural networks. So inspired by this, we put together a method to compute directly the values as required, thus minimizing the need to store these results. And this approach, although it saves some RAM, it has a trade-off of a small higher latency. But I have to say, I think our customers are mostly RAM constrained than latency constrained. But you still have the other option if you want to go faster. Here is here it's an example on of the peak RAM usage on the MobileNet V2 architecture for the latency optimized, so 2.4 megabytes of RAM. And with the Ion compiler RAM optimized, we achieved 951 kilobytes of RAM. This is a great improvement. I can see usually we have a kind of a save between 30 to 50% compared to what we have with the default TensorFlow Lite for microcontrollers compilation. Okay, that's it for me. I'm not sure, Linda, if you want to go with a giveaway right now, or if you prefer that I take questions now. I'll let you decide.
Yeah. Yes.
Thanks a lot, everyone.
Yes, I can announce the giveaway winner. It is random drawing, so we will email you, but the winner is Long Feng. So this Jetson or a Nano will be coming to you soon. I'll email you to get your mailing address. So thank you, everyone that is here today. So a few questions for you. I'm going to try to answer a few questions that haven't been answered by the moderators yet. One is, can you please share where to find the hardware acceleration examples for Linux?
Yeah, it's in the documentation. I'll let someone in the moderation come back to you.
Okay, great. There's another question around, are there any plans for iOS Android deployment options?
So this is a question we've been discussing internally. I have to say Android and iOS support C++, so you could do that. It's probably going to require some fine-tuning and some adaptation, but it should be already doable. Now, to prepare a package, so an export package with an Android or iOS like deployment option, this is not something that is in the roadmap at the moment. But if you have like a strong need and if you have budget as well, we can speak about it.
Question around someone can't upload their training data due to some local laws. So I would say, this is probably like a privacy question. How do we handle PII and that sort of thing?
Yeah, all our user terms and agreements are available directly on the bottom of Edge Impulse website. You can have a look. I, for example, sometimes access users' project when they request the need on the forum. Other than that, we don't sell the data, obviously. But I'll let you have a look at the privacy and user terms. Can't even remember the right name, but yeah.
Mm-hmm. Yeah, and I've seen a couple of questions on this, but as a reminder, this webinar has been recorded, so we'll send a link to the recording and the slides afterwards. So Louis was sharing a lot of QR codes that link to more detailed docs. If there's an area that you want to do a deeper dive in, you can get all the details there. So we'll be sending and posting the recording of the webinar and the slides shortly after this live webinar ends. Let's see if there's any other questions that haven't been answered yet. Can you tell me more about your audio recognition algorithms and how they work, and which is pre-processing?
Yeah, so for the audio, so the keyword spotting models, you can have different approaches. First is the way you will extract your data. By default, with Edge Impulse, we have three main options. One is using the MFE, so male frequency. Well, I can't exactly remember how it's the definition. So MFE or MFCC or spectrograms. Those are the three main feature extractor that you can use. And I have to say, like in the audio part, most of the compute is done through the DSP in the DSP. And then when you want to train the neural network, you have two possibilities. Either you use like neural networks or deep neural networks that can be 1D convolutional or 2D convolutional. We also put together some pre-trained models, so using some transfer learning techniques to extract, so to reuse a base knowledge of audio, and then fine-tune the last layers only with your extracted features. So this will help you to achieve good accuracy while having a limited amount of data. So those are the different options that you can go through.
Great. The question around the Linux CLI, is there something similar available in the context of Windows?
Good question. So I haven't not been using Windows in a while. I think we're still tied on the Edge Impulse Linux CLI to some Linux dependencies. That being said, the Linux CLI works on macOS, and I know lately Windows has opened like kind of a new terminal, so I'm not sure if this is available or not. I have to say I haven't been testing it out in a while, so I'm not sure.
There was a question about if we do consulting. If you have questions that are related to sales, you can always contact us, and I'll put the link to our contact us page here and have a conversation with sales. We don't do consulting per se, but for enterprise clients, we have some advanced kind of professional services. Question about when there are multiple signals in the same waveform, is it possible for Edge Impulse to separate them and output the individual signals?
I would need probably an example. That being said, when you have your data sample, usually we still store the axis. So if you have X, Y, and Z, it's not like all messed up. So we have really three axes within that data sample. And then you could use dedicated DSP blocks per axis. I'm not exactly sure if I answered your question. But yeah, as we're using all the information, you can always like use some pre-processing techniques to extract some information from your raw signal that could split the signals. But I'm not exactly sure about the use case here. Feel free to reach out again if you need.
A few more questions about data privacy. Can you speak a little bit more about how do we handle data privacy and make sure your data is secure?
Okay. Well, first of all, we are SOC 2 Type 2 compliant, which is super important when you are working in the SaaS industry or basically any software company. We have a high level of security. And then on the data privacy itself, we never touch your data. So we never, your data is yours. We don't sell it. What we're selling you is a way to extract meaningful information from those data. so you can train your networks.
Question on what models do we use for computer vision? Oh, and one of our admins just answered that, but if you want to speak to it as well.
Yes, computer vision, we support image classification, we support object detection through various techniques. Most of those techniques involve using pre-trained models. You can select different backbones, whether it's MobileNet, V1, V2. I've seen also some efficient net, ResNet. You can also import your own architecture if you want. And we also have our own, an architecture that we developed ourselves, which is called FOMO, and stands for faster objects, more objects. And instead of getting the bounding boxes, so the actually size of the box, we just output the centroid. And this tip or this trick actually saves you a lot of resource on your device. I've been giving several conferences around this topic, as well as my other colleagues. Feel free to search online FOMO if you're interested. We go into details in how this works.
Great. One very important question was, have you been scuba diving in Hawaii?
I've never been to Hawaii ever.
Okay, you'll have to change that. Can you go to, you might need to refresh your presentation, but if you go to the next slide, Louis, I just wanted to make sure everybody knows how to get in contact with us. If you go to edgeimpulse.com/contact-sales, you may have to refresh your presentation. That's how you can reach us if you're looking to, if you're working on a professional project and you want to get access to all of the advanced features, please contact us, and we have a team that would be happy to go through your specific use case and how we can best help. So just go to edgeimpulse.com/contact-sales. Or if you go to our homepage, you can also request a demo there. Yes, and I just saw another question about technical one-on-one interaction. That's the best way to get in touch with the team.
So one-on-one interaction, I believe, like if you have a business use case, you can go to contact sales. Otherwise, like on the developer relation team, we spend plenty of hours per week on the forum. So we'll be happy to guide you through or provide you some feedback. So it's forum.edgeimpulse.com.
Great, thanks. All right, well, we're going to wrap it up a few minutes early. Again, I just want to say thank you for everybody for joining today, and a huge thank you to Louis. Excellent job. I know you covered a lot of information in a very short amount of time. So again, the recording and the slides will be available a little bit later today for folks if you want to deep dive into any section. So thanks again, Louis, and for all of
everyone for joining.
Yes, thanks everyone for joining, and for the moderators for answering all the questions. So have a great day, everyone.
Bye. Thank you.